Okay, in this video, we'll look at a more general form of a characteristic equation of a circle. So for this, we will locate the center of a circle at a general point. So here the center will be located at A, B, at the point A, B. So for the sake of the argument, let's say the circle has a radius R. A more general form would be a circle which also intersects both the x and y axis, but we don't have to go into that extremes. So this would represent a general case. So let's say this is R, the radius is R. So how do you obtain the characteristic equation? So characteristic equation means it will give you all the xy coordinates which fall upon this circle. So you're going to obtain it like this. You just first you will locate as a general point x comma y, general point. This is general point. You know that the distance between this point and the center will always be constant. So you know uh, how to obtain the distance between two coordinates in the Cartesian plane. Let's write this down. The difference in x coordinates, x minus a square plus difference in y coordinates. So the center y coordinate is b squared. This should be equal to distance squared. Distance now in this case is r, so it has to be square. So we can simplify it more. This will give us x squared minus 2ax plus a squared plus y squared minus 2yb or by plus b squared. I'm going to take r to the other side, minus r squared is equal to 0. Okay. So I will collect some terms so that it will be more clear. X squared plus y squared. I'm gonna couple these two quadratic terms. Then minus 2ax minus 2by, and the x and y terms. Here you have a quadratic terms and you have linear terms, plus you will get a squared plus b squared minus r squared is equal to 0. So this is a constant. This is a constant. So this would be the general characteristic equation of a circle. So if you see a characteristic equation like this, you would know definitely that the locus of this expression would represent a circle. Okay, so let's see if we can obtain the previous equation by substituting 0 comma 0 for a and b, because in the previous video we were looking at a special case where the center is at the origin. So in if the center is at the origin, a comma b should be equal to 0. So in that case you would get this equal to 0, this equal to 0, this part is equal to 0. Finally you get x squared plus y squared minus r squared equal to 0. See how easy it is. Okay, we'll look at an example now. So I don't need to draw x and y axis for this. Let's say the center is minus 1 2, this is the center, and the radius being 3, and you are asked to find the characteristic equation for this. So you can start with the basics, or you could just use the characteristic equation. So in this case, x squared plus y squared minus 2a. What is a? A is minus 1. X minus 2b. What is b? B in this case is 2y plus a squared, that means minus 1 squared, plus b squared, that means 2 squared, minus r squared. 3 squared is equal to 0. So now you can collect terms. X squared plus y squared plus 2x minus 4y plus this would give you 1 plus 4, 5 minus 9, that is minus 4. Okay, this is the characteristic equation of a circle whose center is at minus 1, 2 and which has a radius of 3 units. Okay. Now, given a characteristic equation, let's say that you are given this characteristic equation and you are asked to find what is the center or the radius, center and the radius. Let's try to figure it out in the next video.